Hi everyone, welcome to my learning channel. So today we'll be taking a look at social network analysis. So as a part of a first video in this series, first and foremost, we will take a look at what is a social network analysis. We'll take a look at a simple example given the fact that I work in a banking industry. So I'll take you through one example from the industry itself. And then how do we typically use social network analysis for fraud detection on a day-to-day basis. And then afterwards, we'll be taking a look at one sample example of social network analysis in Python. So this is something that we'll probably capture in the next video. So to get started, let's take a look at a simple example. So on screen, you see 5 different dots. Each of these dots correspond to individual data point. So on the absolute left-hand side, you have John 1. And for corresponding to John 1, you have different informations available. So you have email address for John 1, which is john1@gmail.com. Then you have phone number, which is 1234 address ABC Street. And similarly for John 2, you have email address of as john2@gmail.com. Phone number as 1234 and address is XYZ Street. Now, as you can see that John 1 and John 2, they have same phone number, which is 1234. So that's a commonality between John 1 and John 2, and that's how they are connected to each other. So as a part of a social network analysis, this is something that you will see that everything that is part of one network will have some sort of a data point which is common between each of these individual data points, or you can call them a node as well. Similarly, you can see that John 2 is connected to John 3 via a data point called email address, which is john2@gmail.com. And similarly, you have 3 connected to 4 via phone number, 2 connected to 4 via address. But as you can see that John 5 is not connected to any of the other data points, and that's why it's been denoted in red. So any of the data points, which is like email address, phone address for John 5 is not common to any of the other data points that you see in the network. So in a way, you can say that John 1, 2, 3, 4, they are part of the same clusters. They are part of the same social network. John 5, on the other hand, is not part of that cluster or the social network. So that's typically how you would build any kind of a social network. You will take a look at all of the data points and you will see that what are the things that is common between them. Sometimes it is their spending patterns. Sometimes it could be where these people live, or sometimes it could be they are actually friends with each other or not friends with each other. So depending upon the use case, you will be forming the different social networks, and you will see that you will have a cluster of data points that could be classified in like a different categories. So we will be taking a look at that. So let's take a look at one of the sample use cases in banking fraud detections. So on screen again, you have 4 different signals. Let's just say that this is signal 1, 2, 3, 4. And these signals are coming at different point in time. So let's say signal 1 is coming at 5 a.m. in the morning, signal 2 is coming at 6 a.m., signal 3 at 7 a.m., and signal 4 at 9 a.m. And all of these signals are being processed by your bank. So let's say signal 1 has details that it pertains to a particular account. Let's say that account ID is 1, and then you corresponding to that signal, you have a device ID, which is 1234, IP address is 1.1.1, and then phone number as 1234. Similarly, for signal 2, you have similar information, account ID 2, device ID 1234, IP address 22222, and then phone number is 575678. So as you can see that signal 1 and signal 2, they have same device ID, which is whoever is logging in, whoever is trying to access account 1 and account 2, they are doing it using the same device ID. And similarly, between signal 2 and signal 3, as you can see that they have same IP address, signal 3 and signal 4, they have same phone number associated to the account. Now, what if I tell you that right around 5 a.m. when the signal 1 came in, you already know right afterwards that signal 1 is a fraudulent transaction. It's not been initiated by the real customer, but rather it's been initiated by a bad actor. So once you have that information, now you know that everything that is related to this particular signal, which is your account ID, device, phone, and IP address, is associated with a fraudster. So the moment you have signal 2 coming in, you will actually intercept it, and then you will take the mitigating action. So you're not going to let this customer access their account or whatever this customer is trying to do, because now you know that it's not been done by a good customer, but rather it's been done by some fraudster who is trying to hack into or trying to get access of the customer's account. So most of the bank in the financial industry you will see will have sophisticated fraud controls, and this is sort of a very simplistic fraud control that most of the banks will have. The moment you have any kind of fraud incident happening, everything that is associated with that signal will be leveraged to assess that any of the subsequent signals, if they do have it, if they do have some signal like that, will be leveraged as a part of your risk assessment, and then you will use that for taking any kind of a mitigating action. So moving forward, let's take a look at some of the component, or I would rather say types of a social network. So I've just picked like two very simple examples, two very extremely different example. One that you will see like most of the time on your day to day, and another one that you will never see, especially in the banking industry. So the first one is a centralized social network where you will have one center node, and pretty much it is connected to all of the other nodes that is there in their vicinity. This is something which is very theoretical in nature. At least in the fraud detection, you will not find something like this ever. Fraudsters are fairly smart. They do try to mask most of the information that pertains to them with the sophisticated softwares or even the hardwares. So that's why you will not see something like this in the real world. On the right hand side is the fragmented, and this is something that you will see most of the time in your fraud detection world. So you will have a burst of a signal which is coming from, let's say, one particular network, and then you will have another burst of the signal that might come later on, maybe minutes, maybe hours, maybe days, and there might be some sort of a commonalities between them, and that commonality could be very weak. That is something that you will have to determine. So all the examples that we have seen so far, which is having the same device, same IP address, or same phone number, etc., that is something which is fairly easy to determine and fairly easy to implement. But in the real life, you will see that fraudsters are fairly smart. So a control like that is not going to be very useful. So you will have to design a control which is more probabilistic in nature, which can potentially tell you that how are these two nodes or how are these two signals sort of related to each other. But we don't have to go into the details of that at this point in time. We just need to understand what does social networking mean, and then how do we use it on the day-to-day basis. So that's a very brief introduction of social network analysis. In the next video, we will do some data preparation. We'll be building a social network as well. So this is an umbrella term. This actually includes some multiple steps. So first of all, you'll do a little bit of a data cleaning. Then you will have to prepare the edge nodes, the connection between all of these nodes. And then finally, you'll be doing the actual network building. And then finally, we'll be doing a visualization. Now, visualization is again something that you would never do in your real life, because in the real life you'll be dealing with like millions of data points, so doing a visualization with that is going to be very, very difficult. So for the most part in the real life, you will be doing something like you will be looking at just like some key stats. So I'll take you through both the exercises, which is doing the visualization as well as taking how to calculate some of these key stats. So that's all for today. Thank you so much, and please stay tuned for the next video.